The number of people that have certain diseases are exponentially increasing, and the inflection point seems to be around the 1950s. And these include allergic diseases and autoimmune diseases, as well as, quote, metabolic diseases, right? So these would include things like obesity, cardiovascular disease. These diseases exist at very low frequencies in the population prior to this time. And it's probably not just because of folks not recognizing that folks had these diseases. Since our genes don't evolve that fast in a 70-year time frame, then it can't be our genes. There must be something different about the industrial modern environment that's interacting with our physiology in a way that's producing disease. Our interest is trying to understand this kind of dark matter in the modern environment and how that's kind of mismatched with our normal defensive capabilities that have kept us surviving and flourishing as a species for so long. And so in particular, we're interested in autoimmune diseases, which are so much more prevalent now than 70 years ago, and allergic diseases, diseases like food allergy, which really didn't exist 70, 100 years ago. Since we're a physiology lab, we look at the whole organism. We challenge a lot of the assumptions of whether or not, even if there's something wrong with a particular organ or a particular cell, if the root cause of that problem actually stems from that organ or that cell where it is. It could be a problem farther away that's impacting this, and this is what you're observing. The root is actually much farther away, so an analogy would be like a roof that leaks. Yeah, there's a hole there, but you gotta find where the leak is coming from, and it could be a dozen different places, and we care about where the leak comes from. We are not limited by the techniques or approaches that we use. We essentially take whatever technique and approach is needed, try to apply the state of the art of that technique and approach to the particular problem. And as a result of this, we're a highly collaborative group. So we work with a lot of folks throughout the Yale ecosystem as well as beyond. Primarily, we just want to understand how stuff works. I think our perspective on this is that really understanding how stuff works will give us a much better chance to address the disease, as opposed to starting with the disease in the absence of kind of the evolutionary design and physiology behind what could have gone wrong that produced disease. As a physician scientist, obviously the dream is for some of that work to then be able to be translated to new drugs and new approaches to treating patients. And by patients here, I mean patients with autoimmune disease, neurodegenerative disease, allergic disease, the diseases of the modern era.